Hey, third graders, it's Mrs. Compton. We're getting ready to do some math. So we've got a story today, and it's all about tomatoes in a garden. And if you're anything like me, you like to grow what you can. So I have tomatoes, I've got passion fruit, I've got raspberries, I've got all kinds of stuff back here. So when we are reading, I really want you to make a picture in your mind. That's like one of the most important things that you can do as a mathematician. Have the visualization of what you're reading about. All right, so here we go. Many people grow tomatoes in their gardens. Lee plants 3 rows of tomato plants with 6 plants in each row. How many tomato plants are there? Okay, so we've got to figure this out. So make sure you read this a second time. You can even hit pause so that you have the picture in your mind. I think I'm going to take a moment to read it once more to myself so I can make sure I have the picture. Okay, so he's going to plant 3 rows of tomato plants with 6 plants in each row. Okay, so I'm going to check this out now. So maybe I'll just even draw myself 3 rows. And then I'm going to put 6 plants in each row. So ready? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so that's one way to think about it, right? I have 3 rows, 6 plants in each row. Or I could just not draw out my lines for my rows, and I could do just like use cubes or blocks. 4, 5, 6. So I'm really visualizing what I'm doing, right? It's very important. Stop to visualize. Okay, so now how would you figure out how many tomato plants there are? So this is the part where it gets fun because we're going to try not to just count them by 1, 1, 2, 3, right? We want to get creative. We want to make connections. We want to think about things that we actually already know and build on those ideas. You want to stretch your brain a little bit. All right, so I want you to hit pause, and I want you to think about these different pictures, and I want you to notice and wonder some things. Okay, so everybody hit pause. All right, so hopefully you hit pause and now you're unpaused. So I'm thinking you may have noticed 6s here are kind of like a 5 and a 1 more. And you probably know how to count by 5s, don't you? Let's see. If this is a 5 right here and a 1 more, and this is another 5 and another 5, it probably makes it easier to count, right? Because you can say 5 and another 5 and another 5 make 15. And then you have 16, 17, 18. So maybe you've just connected the idea to 3 groups of 6. 3 groups of 6 is the same as 3 groups of 5. 3 groups of 5 plus those 3 that didn't make it in. So maybe you're like, oh, I could do that. 5, 10, 15, 16, 17, 18. So this would equal 18, right? All of these. This is 18 and this is 18. Maybe you thought about it like that. Maybe you actually counted by 6s. Let's see if we could do that. Ready? 6, 12. Wait a minute. I bet a lot of you know 6 plus 6 is 12. So maybe you were just like, I know this one, 6, or actually 2 groups of 6 makes 12. And 1 more group of 6, so 12 plus 1 more group of 6 would be 18. Maybe you thought about it like that. I don't know. I'm going to guess that some of you actually counted by 3s and maybe even 2s. So here's my next guess. Did anybody say 3, 6, 9, 12, 15, 18. And you probably thought about it as 6 groups of 3. Is the answer still the same? If we have 6 groups of 3, 6 groups of 3 is still 18. My goodness. And maybe some of you went 2, 4, 6, 8, 10, 12, 14, 16, 18. The strategies are endless, you guys. I'm sure you guys have some good mathematical ideas rolling around in those noggins. I can't wait to hear about them. Tell me in the comments. I'll see you next time. Bye.